In the last chapter, we talked about finding the optimal consumption bundle for a consumer given some income and prices for two goods. We've been using the example clothing and food. This video is going to be about mapping out changes in the optimal bundle if we have changes in either the price of one of the goods, relative prices of the goods, or if we have a change in income. So on this graph, we're looking at consumer optimal baskets when we have changes in the price of food. So here's one budget line with a relatively high price of food. We can only buy a couple units of food. We have a second budget line and a third. And then we have our optimal points. Again, these indifference curves won't cross, but we have a field of indifference curves, one higher, and we could trace these out a little bit further if we wanted so that they were kind of parallel. What this is showing us is that the point of tangency between the first budget line and the optimal indifference curve is point A. We have a point of tangency there. When the price of food decreases here, so we can afford, looks like 12 units instead of 4, the optimal point is B. We have a point of tangency there. And finally, when the price of food, so this must be 50 cents, first $2, then $1, now 50 cents, the optimal point is point D. Right, so same idea that we were doing before, but now we're just tracing out a set of optimal points given some different possible prices of food, and then you can trace out a curve that shows you every possible optimal point for every possible price. So that curve is what we call the price consumption curve. This video is going to be introducing a number of, I guess we'll do 4 or 5 different curves, one of which you already know, the demand curve. And then there's a few new ones, but hopefully you can remember them just kind of by the name. The name for the most part, except for one, tells you more or less exactly what it is. So what's a price consumption curve? A price consumption curve tells you at different possible prices of one good, what are the optimal consumption bundles. So once again, here when the price of food was $2, we could afford only 4 units of food. That was our optimal bundle. When the price of food dropped to 1, now we could afford 12 units. And when the price of food was 50 cents, now we can afford 20 units. So that sounds a lot like something that we've seen before. That sounds like a lot like the demand curve. And there's a direct relationship. Given the information from the price consumption curve, we can trace out, given the price of food. And so now we're not going to deal with the price of clothing. The price of clothing hasn't changed. So this price consumption curve and then the demand curve is just dealing with if the price of one good changes, what happens? And we know we move along the demand curve. So we can actually trace out points on this demand curve to show that when the price of food changes, $2, $1, 50 cents, our quantity demanded of food increases at our optimal consumption bundle for 12, then 20. So a price consumption curve shows us on the same consumer optimization type of graph we've been looking at in chapter 3 with our two goods, good Y and good X, whatever they might be. As the price of one of the goods changes, here good X, food, how does the optimal bundle, how does the optimal consumption change? So when price changes, how does optimal consumption change? Price consumption curve. And then from that information, again, we can go back and trace out a curve that we've already studied, which is the demand curve, which is showing us for one good, the good which the price is changing. When the price changes, how does our quantity demanded change in our optimal bundles? So that is a consumer demand curve stemming from preferences. All right. We also showed when income changes. So here we have kind of a similar concept, except instead of 3 different prices, we have 3 different income levels. So we have low income level, which would be this budget line. We can't buy as much stuff. A medium income level here, and a high income level. We find our points of tangency to find the optimum. They're here, A, B, and D. And then an income consumption curve. In this case, it's a line. Doesn't always have to be a line, but in this case, it's a line. The income consumption curve shows us, as our income increases, what is the set of optimal points. So again, kind of in the name, hopefully you can it'll help you remember in the name, when we have changes in income, what are the changes in the optimal consumption bundles? Income consumption curve. Right, there's actually 2 curves then we can relate this to. The first one is back to our demand curve. So we wouldn't actually be able to see the slope of this demand curve like before. Right here from the price consumption curve, we could trace out our demand curve. We know the slope or shape of this demand curve. Suppose we already knew the slope shape of a demand curve, and then we had this income consumption curve, which traces out as our income increases, how do the optimal bundles change? So again, if we're looking only at food, a demand curve is going to look at only one item. Now, when income changes, that's actually a demand shift factor. So instead of moving along the demand curve, we're shifting demand. We can see that suppose we had this original demand curve, which keeping price constant at $1, right? All of these income levels keep prices constant. We just got more income. So at the price of food, which remains constant at $1 in the original bundle, we were able to buy 4 units of food. So we trace out that point, and then from the price consumption curve earlier, we might have known the slope to know the rest of this information. And we can see that as our income changes, we demand more of this good. Right? Price stays the same, but our entire demand curve shifts. So these are parallel demand increases due to increases in income. Right, the second type of curve that we can trace out from our income consumption curve is an Engel curve. And this one, I think, for me was always the hardest to remember because its name doesn't tell you exactly what it is. But an Engel curve shows you at any different income, what is the quantity of food demanded. So it's very similar to how we mapped out the demand curve, except instead of having the price of the good on the y-axis, we have the consumer's income here instead. And what we can say is that this is a way to show normal versus inferior goods, because for a normal good, the Engel curve will just be upward sloping like this. What's this saying? As we get more income, we demand more food. So that would be our normal good relationship. Income increases, we demand more of the good. We can see, suppose this was an Engel curve. This traces out different incomes. Up to $20, this is a normal good. We demand more hamburgers as our income increases. But then if hamburgers are an inferior good past $20, right, when you get more money, maybe these are McDonald's hamburgers, you substitute away from them and buy something that you like better. So a good doesn't have to be only normal and only inferior. It could be normal at certain income ranges and inferior once you get to a certain income level. All right, going back up here, you can also see inferior goods with the income consumption curve. If you had a backward bending income consumption curve, then we can see here, once again, these are different income levels, different budgets that we could have. And it looks like past about this income level, we start demanding less hamburgers. So a backward bending income consumption curve would show you the same sort of information that a backwards bending angle curve would show you, just slightly different ideas here. We have a second good. Steaks here, I guess, are the superior good. As you get to higher levels of income, you substitute away from hamburgers and towards steaks in this particular example. Okay, so two ways of showing normal versus inferior goods.